Just 1 minute. Okay. Then what we have got next is solution of homogeneous linear differential equation. Now we came to know what is linear differential equation. Then you know when the equation is homogeneous and when it is non-homogeneous. Okay, and these are the two conditions for homogeneous, non-homogeneous. After this, write down next title as solution. Solution of homogeneous. Okay, what is homogeneous linear differential equations. Okay, so for the solution of homogeneous differential equation, let us consider equation in the form. So write down consider. Now tell me d square y upon dx square plus a1 dy by dx plus a2y equals to 0. This is of what order? Can you tell me this is equation of which order? We are saying higher order.
Second order, ma'am.
Second order.
So the highest order present in the equation is this 2. Okay. So it is a second order linear differential equation. It is homogeneous, non-homogeneous.
Homogeneous, ma'am.
Okay, homogeneous because we are having a RHS term equals to 0. So this represents it is a homogeneous equation. Then what are these A1 and A2?
Constants.
These are known as what? Constants, right? So with this, again you can simplify by using the operators. So I can simplify it as t square plus a1d plus a2 into y equals to 0. Is it clear? We have used the differential operator capital D, then taken y common and is equals to 0. So let me write this is nothing but some function of d into y and is equals to 0. Okay, therefore, so what is your f of d? Where what is value of f of t? F of t is nothing but t square plus a1t plus a2. This is a function of t. Is it clear? Okay, so here, see here. Actually, if y1 and y2 are two linear independent solutions, listen to me after this step. If y1 and y2, so see here, if y1 and y2 are two linear independent solutions of what? Of this equation. We have marked equation 1 and 2 no? So far. Okay. Then let me consider this as equation 3. So write down if y1 and y2 are two linear independent solution of equation 3. Okay, so then see here, in the solution, see what will be the order, so many the constants you will get in the solution. So if it is of second order, you are going to get C constant, two constants, C1 and C2. Okay, then what we write, C1 into Y1 plus C2 into Y2. This is also a solution. Okay, this is also the solution of equation 3. Right. So what we are considering, C1 Y1 plus C2 Y2 is the solution, and since the general solution of the second order differential equation has two arbitrary constant. Okay, so second order, always remember how many will be the order or what will be the order of the equation, so many constant you will be getting. Okay, you will be getting so many constant, right? Therefore, now see here, now what we write, solution of this equation 3, we write it as YC. Solution of equation 3 is given by YC equals to C1Y1 plus C2Y2. Right? So now we write that, which implies f of d into yc equals to 0. Now we have the equation in terms of y equals to, and then we have its a solution yc. This yc, f of d into yc equals to 0. So this yc is known as complementary function. This is known as complementary function. Right. So this gives what solution of the given differential equation 1. Okay, basically what differential equation 1 we have considered. Solution of this differential equation is what? F of d into yc equals to 0. So what it says, if your differential equation is homogeneous, so whenever you have a homogeneous differential equation, what will be the order? So many will be the constants in the solution. So since you are having it as second order, so y1 and y2 will be the two solutions. Okay, together we call it as a solution of the given equation. If it is of order 2, you will be having y1 and y2 are two independent solution, and since the order is 2, you will be having c1 and constant, c1 and c2 are the constants in the solution. So we write c1 y1 plus c2 y2 is the solution of equation 3. So this solution we write as yc. Yc is what? Complementary function. Yc is the symbol for the solution of the equation 1 of the homogeneous equation. Okay, so if your equation is homogeneous, then the solution will be consisting of complementary function. Okay, so you remember so much. First of all, if the equation is homogeneous, if equation is homogeneous, okay, if the equation is homogeneous, then solution contains what? Yc. You remember this point. Okay, then what are those y1 y2? How we are going to find? We will explain it. Okay, I will explain it. Okay, I'll explain in general after seeing the solution of non-homogeneous also. Okay, so just you remember, if your function is homogeneous, its solution will be consisting of what? Complementary function. Then write down next. Write the next title as. Do you want me to scroll down? Are you writing? Are you all writing still? Okay, then come to solution of what? That is non-homogeneous linear differential equation, right? Then, so in this, what we do is consider your function f of d. F of d into y. Since it is non-homogeneous, you will be getting here some function of x. Okay. So then we write let y, which is equals to yp of x, be a particular solution. Be a particular solution. Okay. Of, so if I consider in this title this as equation 1, this is a solution of equation 1. Hence, what I write? F of d, instead of y, I write yp. Okay. So what yp stands for? Yp stands for particular solution is equals to y of x. Okay. Therefore, now see here. In simple to say, f of d. Okay, now if I consider both complementary function f of d into yc plus particular integral yp is equals to what? If I multiply, so it is f of d into yc plus f of d into yp. Okay. Now what about this f of d into yc? This is equals to 0. I am going to consider because it is a what? Plus what is f of d into yp? It is equals to phi of x. Therefore, what we consider f of d into yc plus yp is equals to phi of x, which implies f of d is nothing but y. So y equals to yc plus yp. Okay, this is just all theoretical. Just you remember this equation. So when your equation is what? Non-homogeneous. When your equation is non-homogeneous, the solution will consist of both complementary part as well as particular part. Okay. So this gives what? Solution of equation 1. This gives solution of equation 1. So write down where yp represents particular integral. It is also known as yp is known as particular integral. Okay, these are all theories. You just remember homogeneous equation means its solution will be consisting of complementary function, and if you have non-homogeneous equation, the solution will consist both of complementary function and particular integral. Okay, or else it is also given or represent as solution y is equals to complementary function plus particular integral. Okay, is it clear? So therefore now how we are going to find the complementary function, how we are going to write the complementary function. Now here we are going to discuss roots. You know roots, whenever I give you some second order equation or a cubic equation, if I give you second order equation, if I give you order is equals to 2, how many values you are going to give me?
2, ma'am.
How many factors you are going to give me? Factors, or you are going to give me, these are also known as roots. You are going to give me 2 roots. And if I will give you a cubic equation, you are going to give me 3 roots. Okay, so based what are these roots, what is the order of the given equation, so many will be the roots. So now we are going to study what will be these roots, what are the different types of roots you are going to study. Okay, different types of roots what you have. Okay, so see here in general now, if I consider second order, so write down, consider second order homogeneous differential equation in the form f of d into y equals to 0. Okay, second order means what it implies. What is f of d? Previously we wrote, no, it is d square plus a1d plus a2. Okay, then now we write the equation which is known as auxiliary equation. Okay, it is known as a auxiliary equation. Okay, for the above equation, so in short we will write auxiliary equation, and auxiliary equation we write as f of m equals to 0. You have f of d, no, here instead of f of d you write f of m, means what, you are replacing the value of d by m. Okay, is it clear? So what will be your auxiliary equation for the above f of d? You will write, instead of d, I am telling you, instead of d you are going to replace m. So it will be m square plus a1m plus a2 equals to 0. Okay, therefore what are the roots you are going to get? Roots you will be getting in terms of m, right? So m1 and m2 are what? Two roots what you get if your equation is of second order. Okay, now see here, now we have to test these root are real, unique, real, distinct, or they are complex. Okay, so see here, you are going to study three types of root. The first root is, I mean, first root in the sense first type of roots. First type of roots are real and distinct. Can anybody tell me what is meaning of distinct? Real means you know the real numbers. Okay, then distinct means what? Different or same?
Unique.
Okay, unique means different. Okay, distinct means different values. Means here if I go get example, both m1 is also 2 and m2 is also 2, then okay, let me take this example for the second one. If I say m2 is equals to 3, okay, so both the roots 2 and 3 are the real numbers. Okay, and both are different, so we say these roots are real and distinct. Understood meaning of real and distinct? Real numbers and are different. Okay, and the second type of root what we say, it is real and coincident. Coincident, can you guess? Coincident means what? It is same. Okay, so suppose m1 is equals to 4, and if I get m2 is also 4, both are what? m1 m2 are same, so these are the real number, of course, then they are same. So these type of roots where they are real and same, these are known as real and coincident. Okay, then third type, Third type, if you are going to get a complex pair. Hmm? Can you tell me when you are going to get the complex roots? If I give you on second order equation, then when you get the complex roots, see here, if I give the equation, if you are not able to find the factors by splitting up of the middle term, you are going to use this formula, no? Minus b plus or minus square root of, do you remember something?
B square minus
B
4AC.
square
B square
minus
minus 4AC.
4AC by 2.
divided by 2a.
Divided by 2. When you use this formula, you are going to get sometimes complex pair, no?
Yes, ma'am.
Okay.
Yes, ma'am.
When under the root you get a negative number. Okay. Under the square root, if you get a negative number, okay, that is imaginary number, it is converted. So when, what is complex pair? Complex numbers. Z is equals to x plus iy. This is a complex number. X is known as what? Which part? Real part, imaginary part?
Real part.
Then y is known
Real
as
Imaginary part.
imaginary
imaginary
part.
parts.
Okay, so here you are going to get some number consisting of real part plus imaginary part. These type of roots are known as what? Complex pair. Okay, so what are the three different types of roots? So for this, if I give you the example, 2 plus or minus 3i, correct? This can be considered as one of the example. 2 plus or minus 3i. Okay, this is a complex number. This is known as a complex root. So what are the two roots present here? 2 plus 3i, and second one is 2 minus 3i. Okay, these are what? These are known as which type of roots? These are known as complex roots. Okay, so these all three types of roots are clear to you. First one is real distinct, second is real same, third one is complex roots or complex pair. Is it clear? We are getting here two values. So it is complex pair. Have you all written it? Okay, so after knowing the different types of root, now we will write the solution depending upon type of the roots. Okay, so let us consider case 1. Case 1, if the roots are real, so shall I write, okay, roots are real and are what? And are distinct. So write down. So in symbol it is m1 not equal to m2. So when you have the roots and real and distinct, the solution, okay, solution for the differential equation y is nothing but complementary function yc, written as c1. Since it is second order, you are going to get c constant, c1 and c2 two constant. So c1 into e raised to m1x, okay, plus c2 into e raised to m2x. Please remember this. When your roots are real and distinct, how you write the solution? c1 into e raised to m1x plus c2 into e raised to m2x. Okay, is it clear? If only two roots are there, you will consider only m1 and m2. Okay, if you have some fourth order, fifth order equation, then what you can write the solution? If you are having m1, m2, m3, m4 and so on, so many roots, then how you will write the solution? As many roots you have, so many terms you write. Okay, so this will become your y1, this term will become your y2. So c1 y1, c2 y2, what represented in the earlier form. So if you have so many roots, so c1 into e raised to m1x plus c2 into e raised to m2x plus c3 into e raised to m3x plus and so on up to some nth root. So it will be what? Cn e raised to m n x. Is it clear? For the case 1, how you write the solution? Yes? All of you?
Yes, ma'am.
Okay, then go for case 2. Case 2, can you tell me what is case 2? Roots are which type? Roots are real and same. Okay, so real and same means I consider m1 and m2. m1 is equals to m2. So both are same means I'll represent in general as m. Okay, m1 and m2 are the two roots, but both are same. Both are same means I can write them equal. So equal means together I can represent as some general m. Okay, therefore if these type of roots you have, then what will be the solution? Y is equals to yc is equals to c1 plus c2 x into e raised to mx. Okay, when you are having same root, you will write c1 plus c2, you will multiply one variable x, then e raised to the power m into x. Okay, so suppose can you tell me if you have m1 m2 m3 and so on up to mn and all are m only, what will be the solution? How we will write the solution if you have so many roots? It is c1 plus c2 into what you have multiplied x. Okay, then what is there x present with c1? No. Okay, then there is one x present with c2. Then what will be third term? It will be x square plus c4 x cube. Is it clear? Plus and so on up to what will be general term? If it is 4, it is 3. If it is 3, it is 2. So it will be, if it is n, x raised to what?
N minus 1.
N minus 1 and e raised to mx, this will remain same. Okay, so is it clear all of you? Second type, how to write the solution? Then if you have third type of roots, that is m1, m2 are complex root. If you have the complex root, suppose it has p plus I into q. Okay, previously I told z is equals to x plus iy. You can consider like this, or you can write it as p plus I into q. Then if you have complex roots, then the solution y, or it is written as complementary function yc. This will be given as, you have to multiply e to the power px into c1 cos this qx plus, okay, c2 have to multiply. It is e raised to px into c1 cos qx plus c2 sin qx. Okay, so see once more. E raised to the real part P, you will take here, E raised to Px plus C1 into cos the imaginary part Qx plus C2 into sin Qx. Okay, this is if you are having M1 and M2 are the two complex root. Okay, so if you have a repeated root, suppose P plus minus I Q, then you have one more P plus minus IQ. Okay, suppose if you have fourth order equation, you will be having four roots and the roots are repeated. Okay, then how you are going to write the solution for this type? Y equals to YC is written as E raised to Px into repeated means in case 2 what we did, we took what, C1 plus C2x, this should be multiplied with cos Qx plus 4 roots, no, so we will take again C3 plus C4 into x into sin Qx. Okay, so is it clear? If you have repeated roots, these are what? 2. 2 repeated root means how many roots? Totally 2 repeated roots means total you have 4 roots here. Okay, 4 roots means how many constant? 4 constants, C1, C2, C3, C4. Since they are repeated, you write it as C1 plus C2x into cos Qx plus C3 plus C4x into sin Qx. Okay, you have to take e raised to px common. So is it clear all of you? How to write the solution for the type of root? All I have written all 3 types.
Yes, ma'am.
What is time? Is it time up?
Yes, ma'am.
Okay, fine. Then
Yes, ma'am.
for today you write this much, and after the class in the evening you just go through all these 3 types of roots and their solution. Only if you know, then we can solve further examples. Okay, all of you practice this. Okay, fine then. We'll wind up today's class. You can go for a break. Just a minute, I'll take attendance.
Thank you, ma'am.
Okay.
Thank you, ma'am.
Okay, so attendance is very less. Huh? Aditi is here.
Thank you, ma'am.
Aishwarya,
Yes, ma'am.
Anisha, Anupama,
Yes, ma'am. Yes.
then Geeta,
Yes, ma'am.
Kirti, Komal,
Yes, ma'am.
Komal is here. Lakshman Gowda, Manju,
Present, ma'am.
okay, and then
Yes,
Om,
ma'am.
Misbah, Megha, Murgesh,
Yes, ma'am.
Nandita,
Present, ma'am.
Pradyum, Pratiksha,
Yes, ma'am.
Prerna,
Yes, ma'am.
Priyanka, Rachna, Ritin.
Yes, ma'am.
Okay, fine. Okay, all can leave now. Okay, bye. Take care.